In part 3 of our lesson on the half-angle identities, we will do applications of the half-angle identities. In this first example, we are given that the sine of s is negative 2 root 2 over 3, and that pi is less than s is less than 3 pi over 2. So this inequality tells us that s lives in quadrant 3 between pi and 3 pi over 2. So we can draw in s there. Now we know that the sine of s has to equal its y value divided by r. So the y value is going to be negative 2 radical 2, and r is going to equal 3. Because we are in quadrant 3, we know that the x value will also have to be negative. So as I always recommend, make sure you get that in there right away. Then x is going to equal the negative of square root of r squared, so 3 squared, minus y squared, negative 2 radical 2 squared. So that's going to be negative radical 9 minus. Now here we know a negative, when it gets squared, is going to become positive. 2 squared is 4. Radical 2 squared is 2. So 4 times 2 is 8. We get negative radical 1, which we know is negative 1. So we know our x value is going to be negative 1, and we come over here and get that in the picture. So now we have all three sides of the triangle for angle S. The first item that we have to find is the quadrant of S over 2. We were given that S is between pi and 3 pi over 2. So if we want to know the quadrant of S over 2, then we can just take each piece of that inequality and multiply it times 1/2. Then the inequality will become pi over 2 is less than S over 2 is less than 3 pi over 4. If S over 2 is between pi over 2 and 3 pi over 4, think about where that is in a picture. Here's pi over 2. Here's 3 pi over 4. S over 2 lives between those. So then that means S over 2 is in quadrant 2. Next, we have to find the sine of S over 2 and the cosine of S over 2. In each case, we will start from the identity. The half-angle identity for sine of S over 2 is equal to plus or minus the square root of 1 minus the cosine of S divided by 2. Now, we can decide whether this will be positive or negative based on the quadrant of S over 2. And we determined already that S over 2 is in quadrant 2, which means we choose positive. We know that the sine of any angle in quadrant 2 is going to be positive. So this will equal the square root of 1 minus. We go to our diagram now and see that the cosine of s is equal to the x value, which is -1, divided by r, which is 3, and then we have to divide that whole thing by 2. Everything's under the radical there. If we get a common denominator, this would be 3/3. So 3/3 plus 1/3 is going to be 4/3, and that's over 2, everything under the radical. This turns into the square root of 4/3 times 1/2, because dividing by 2 is multiplying by a half. The 2 goes into 2 once, goes into 4 twice. So this becomes the square root of 2/3, which of course is radical 2 over radical 3, and we have to rationalize that. So we multiply by 1 in the form of radical 3 over radical 3. So then this will become radical 6 in the numerator and 3 in the denominator. So now we have the sine of s over 2. Next, we have to find the cosine of s over 2. And looking at our list of identities, we see that's going to be plus or minus the square root of 1 plus the cosine of s divided by 2. We can determine whether this will be positive or negative, because if s over 2 is in quadrant 2, we know that the cosine will have to be negative. So this will equal negative square root of 1 plus, we've already said the cosine of s is -1/3, and we put that whole thing over 2. This will equal negative square root. In the numerator, we have 3 over 3 minus 1 over 3 is going to be 2 over 3. In the denominator, we have that 2 still. This turns into negative square root of 2/3 times 1/2. Dividing by 2 becomes multiplying by a half. The 2 in the numerator and denominator will cancel. So this becomes negative square root of 1/3, which we know is negative radical 1 over radical 3, and we have to rationalize. So we'll multiply by radical 3 over itself. Then this becomes negative radical 3 over 3. And this is the cosine of s over 2. In this example, we are given that the tangent of theta is -1/2, and we're given the inequality that 3 pi over 2 is less than theta is less than 2 pi. We are being asked to find 3 items: the quadrant of theta over 2, the tangent of theta over 2, and the cosine of theta over 2. It's CYU time, so pause the video, work the example on your own, then restart the video to check your answer. Now the first order of business will be to draw a picture of theta, and because of this inequality, we know that theta is going to live in quadrant 4. Here's theta. Now we can start labeling the sides of the reference triangle here because we're given that tangent of theta has to be negative 1/2. So we know the y value over the x value has to be negative 1/2. And in quadrant 4, it's the y value that will be negative because the x value has to be positive. So y will equal negative 1 and x will equal positive 2. We know that r is equal to the square root of the x value squared, so 2 squared, plus the y value squared, negative 1 squared. So 4 plus 1 is 5, so r is going to be the square root of 5, and we label that in our picture. To find the quadrant of theta over 2, we'll start with that inequality of 3 pi over 2 is less than theta is less than 2 pi. And because we are interested in theta over 2, we're going to want to multiply each piece of the inequality by 1/2. Then our inequality will become 3 pi over 4 is less than theta over 2 is less than pi. So looking at a picture of that, we know 3 pi over 4 lives here, pi lives here, so theta over 2 has to live between those two, which means that theta over 2 is in quadrant 2. Next, we have to find the tangent of theta over 2 and the cosine of theta over 2. Now, looking at our list of half-angle identities, we see we have several choices that we can use for tangent of theta over 2. I think probably the easiest one to use would be one where we don't have to determine the plus or minus sign and we don't have to take a radical. So I'm not going to use that first one. Now looking at the next two, they're both pretty easy to use, but I'm going to choose the one with the simplest denominator because why not have the easiest thing possible in the denominator, less to simplify later. Now, one of the things that we notice about all of the identities for tangent of theta over 2 is that they all involve sines and cosines. So looking at our picture here, we can see we're going to need the sine of theta and the cosine of theta in order to plug into the identity here. Now, the cosine of theta we know has to be the x value, which is 2, divided by r, which is radical 5. I would suggest that you write this out and go ahead and rationalize it first before we try to plug it into the identity. So we'll rationalize by multiplying by rad 5 over rad 5 and we get that the cosine is 2 radical 5 over 5. The sine of theta is the y value, -1, divided by r, radical 5. Once again, we're going to rationalize radical 5 over radical 5, and this becomes negative radical 5 over 5. Now we're ready to use these identities and find the tangent of theta over 2 and the cosine of theta over 2. Tangent of theta over 2. Of those three choices, remember we said let's use 1 minus cosine theta over sine theta. And this is just a personal preference. I think it's easier to handle the one with the simplest denominator. So this is going to become 1 minus cosine theta, which is 2 radical 5 over 5, divided by sine theta, which we said is negative rad 5 over 5. We have a complex fraction, so we will multiply by 5 over 5 to clear that out. This is going to become 5 has to distribute over the numerator, so 5 times 1 is 5 minus 5 times 2 radical 5 over 5. Well, of course, the 5 in the denominator here will cancel with the 5 in the numerator here, and we get 2 radical 5. In the denominator, when we multiply, the 5 here will cancel with the 5 here, and we have negative radical 5. We know we can't have a radical 5 in the denominator, and we probably want to get rid of that negative sign in the denominator, so let's multiply by negative radical 5 over itself. It would have been okay if you just did radical 5 over radical 5, and then you could deal with the negative sign later. We're just going to do it all in one step here. So this becomes, we have to distribute the negative radical 5 over the numerator. So negative radical 5 times 5 becomes negative 5 radical 5. Negative radical 5 times this minus 2 radical 5 will become a plus. Then we have 2 times 5 is 10. In the denominator, a negative times a negative becomes a positive. Rad 5 times rad 5 is 5. We can factor a 5 out of the numerator, and we have negative radical 5 plus 2 left over 5. Now the 5 in the numerator and the 5 in the denominator will cancel, and we find out that tangent of theta over 2 is equal to, we could write this as negative root 5 plus 2, but it's very common to put 2 minus radical 5. Now we're ready to find the cosine of theta over 2. And we know from our list of half-angle identities that's going to be plus or minus the square root of 1 plus cosine theta divided by 2. Remember, we discovered that theta over 2 was in quadrant 2, and in quadrant 2, we know that the cosine has to be negative. So this is going to become negative square root of 1 plus the cosine of theta we said was 2 radical 5 over 5, and that whole numerator has to go over 2. We have a complex fraction here. We're going to clear that out by multiplying by the LCD over itself, so 5 over 5. And all of this is taking place underneath the radical here. Now this will equal negative radical. We have to take this 5 times the numerator here. So 5 times 1 is equal to 5 plus 5 times 2 radical 5 over 5. Those 5's will cancel, and we have 2 radical 5. In the denominator, we have 2 times 5, which is 10. We know we're going to have to rationalize this denominator because right now the denominator is radical 10. So if it were 100, that would be the perfect square. Then we know square root of 100 is 10. So at this point, why don't we, underneath the radical here, let's multiply by 10 over 10 so that we know we're going to get a perfect square in that denominator. This will turn into negative square root. In the numerator, we have to distribute. We get 10 times 5 is 50 plus 10 times 2 radical 5 is 20 radical 5. In the denominator, we have 10 times 10 is 100, and we know that that 100 is going to come out in the denominator here as a 10, and the numerator is radical 50 plus 20 radical 5. And that's the simplest form. There's no perfect square that we can pull out of there. So this is the cosine of theta over 2.